Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hello y'all, we're back on dynamics. We're doing a third law problem today. Thank you for watching. I hope your dynamics unit's going great for you. I know you can do it. Hang in there, keep working at it. They get easier the more you do. But today we're doing a third law problem. So we have 3 blocks. We have a 2 kilogram, a 4 kilogram, and a 6 kilogram block. And what they're asking for is find the contact force of the 4 kilogram block on the 6 kilogram block. And then the second part of this is find the contact force of the 4 kilogram block on the 2 kilogram block. So these blocks are touching, they're interacting. All right, as the 2 pushes on the 4 equally pushes back on the 2. As the 4 kilogram is pushing on the 6 kilogram, the 6 kilogram is equally pushing back on the 4. It's the same concept as if you have like a Hummer going down the road and it hits a small little car. The force that the little car puts on the Hummer is equal to the force the Hummer puts on the little car. However, the little car has less mass. It doesn't work out as well for it in those kind of situations, right? So that's kind of what we've got going on here, but we have 3 blocks. Okay, so now we're going to talk about how we do free body diagrams. First of all, if you're doing these interacting forces, you always have the same amount of free body diagrams as you have blocks. So we have 3 blocks, the 2, the 4, and the 6. So we're going to do these free body diagrams. All right, first of all, our clues. We're on a surface, so we know we have normal. So I'm going to write normal here, and that's for that 2 kilogram block. All right, so I'll use the subscript 2. I know I have force due to gravity down that is actually equal to each other. They're balanced because these blocks are not coming off the ground vertically at all. They're only moving horizontally. All right, and they are accelerating. There's this unbalanced force here. All right, then we have, and I'm going to tell you that there's no friction on this one, just for time purposes that we have no friction. All right, if we did, each one of these diagrams would have another little friction opposing motion. All right, now we are at the 2 kilogram block. It has a force of a push to the east. So I'm going to do a force of a push here. All right, and that will be the only one that has that in the free body diagram. Yes, they're all getting pushed, but you only put the force on the one that physically touches it. So that force of the push is the one that was actually applied to that block. All right, so that's why it only appears on this one. Now we also have a 4 kilogram block that's pushing back this way on the 2 kilogram. So I'm going to put that in here. I know it's accelerating to the right, so I know these are unbalanced, and I'm going to call that a contact force. And I'm going to call it contact of force, the 4 block on the 2 block. So we have kind of a subscript to our subscript. All right, so contact force, and that's the 4 block on the 2. And you're like, wait, but Beth, you're missing a force. Isn't the 2 applying a force on the 4? Yes, and they're equal, right? This contact force of the 4 on the 2 is equal to the 2 on the 4. But on a free body diagram, very important concept, you only put the forces that are acting on the object, not what the object is doing and the forces it's applying. So these are our 4 forces. Now we're going to go over to the 4 kilogram. All right, 4 kilogram, I have the 2 kilogram block pushing on the 4 to the east. So I'm going to call that and those have to be equal. If I did them at the same length, they have to be equal because we said these are third law pairs. That means for every action, there's an opposite and equal reaction. So that's the force of the contact, but this time I'm going to call it 2 on 4 instead of 4 on 2. All right, I still have normal. It's a little longer than the other one because it's got a little bit more mass. Still equal in the vertical direction with force due to gravity, that normal is, because it's not coming off the ground vertically. And now I have this 6 that's pushing on the 4. So I'm gonna draw my little contact force here. I have force of contact of the 6 on the 4. And I'm done. Again, I'm not putting that force of the push on this one because it physically came in contact. The force was applied to the 2 kilogram. All right, now I've got the 6 kilogram. The 6 kilogram, I got a little slightly longer normal because it's got more mass, which means more force due to gravity. And this would be the 2, the 4, and the 6. So hopefully those are pretty equal. All right, and the 6 only has the 4 pushing on it. So it's got a force of contact of the 4 on the 6, and I tried to draw those equally. All right, perfect. Now, we are going to get started. That's it. We have our free body diagrams, and now it's time to get started. But here's the clue on these. The strategy on these interacting blocks is find your acceleration first. So the strategy, here's the first step was FBD. Second step is find your acceleration by summing the forces by, here I'm just going to write so I don't have to write this out and take up more time, by summing the forces as a system. Okay, then your third step is going to be then to find those individual contact forces. Find the individual contact forces with an individual block. Okay, and that's individual is what that means. Sorry, I abbreviated there. But find your contact force with an individual block. Those are your 3 steps. So we already did the free body diagram. Check. We're on step 2. So step 2, we're going to sum those forces as a system in the X, because these blocks are moving in the X. When you do it as a system, it's very important. You have to have the total mass because you're using the whole system. In other words, you're going to think of this as one big block. All right, so, but we're going to sum our forces in the X. I have 1, 2, 3, 4, 5 forces in the X. All right, but look at this. Force of contact of 4 on 2 is equal and opposite directions to 2 on 4. So they cancel out. So I could write that my force of contact of 4 on 2 was negative, but then I have a positive force of contact of 2 on 4. So really all you're going to do is write down all your forces in the X direction, but some of them are going to cancel out. So I'm going to go ahead and keep going with this first block. I have a positive force of the push. Now I have a negative force of contact of my 6 on 4. And then I have my positive force of contact of 2 on 4. And then I have a positive force of contact of 4 on 6. And that's going to equal my total mass, which is that the mass of the 2nd kilogram, mass of the 4th kilogram, mass of the 6th, all times the acceleration. All right, look at this. 4 on 2, 2 on 4, opposite directions cancel out. Woohoo! Makes us happy, do a little happy dance. We have the contact force of 6 on 4 is equal, opposite and equal forces. So 6 on 4, 4 on 6. So woohoo, those work out too. We love that. We are left with only one force when we do a system. And remember, this is the system. And that's the force of the push equals all 3 of those masses, which is M2 plus the M4 plus the mass of the 6 kilogram times acceleration. I'm going to find an expression for that. I'm going to divide that force of the push, divided by both sides, divide both sides by M2 plus M4 plus M6 equals your acceleration. Now I'm going to go plug in numbers for that. My force of the push was 30, so I have 30, and then that's 30 plus 2 plus 4 plus 6 equals acceleration, and that acceleration comes out to be 2.5 meters per second squared. Okay, perfect. Now, that's great. So now we have that, but that's just not what they asked for. They asked for find the contact of the 4 kilogram on the 6 and then the 4 kilogram on the 2. So great, we have acceleration now, but that's not really our real answer. But we have to find acceleration first. That's critical. I'm going to switch to blue. I hope you can see that, but I'm going to switch to blue here, and I'm going to kind of draw a little line so we can see this. Once we get to our acceleration, now we use an individual block to find the forces. So the first thing they wanted was the force of the 4 on the 6. All right, you're like, oh, I got that. The force of the 4 on the 6. You could use this one because these are equal, right? The contact of the 6 on the 4 is equal to the contact force of the 4 on the 6. This one was pushing this way, this one was pushing back equally. All right, well this one only has one force in the x direction. That looks way less complicated than one with two. Plus, I don't know this yet, so I wouldn't have enough information to use this block. So I'm going to use this block. So I'm going to say, hey, I'm going to sum my forces on the 6 kilogram block in the x direction, and that's going to be the mass of the 6 kilogram. I only have one force. It's the force of the contact of 4, what that 4 was pushing on the 6. My mass is, oh, and they wanted this contact force, so I've already solved it. I'm good, right? This is what we've got. We're going to sum the forces in the x. We've got that equals mass times the mass of that 6 kilogram times the acceleration in the x. All right, well, my contact force of 4 on 6, again, sloppy with my vectors, sorry, equals mass of the 6, which is 6, and my acceleration we just found was 2.5. So, go figure, that's going to be 6 times 2.5 is 15 newtons. That means that 4 kilogram block was putting 15 newtons on the 6 kilogram block. And the 6 kilogram block was equally putting 15 newtons on the 4 kilogram. Opposite and equal. All right, so that's what we get for the first one. So we're done with that one. We love that. Now we're to the second one, and we want the 4 kilogram on the 2. All right, we have 2. We could use this one. The 2 on the 4, because we know it's equal to the 4 on the 2. You could use either block. You could use the 2 kilogram or the 4 kilogram, and they both have equal amount of forces. It doesn't matter. Here's the deal. Don't sweat it. Oh no, which one do I use? You'll get the same answer. Doesn't matter as long as you plug in the right numbers. So I'm going to go ahead and erase this right here, and we are going to do we're going to do the last part of this, and then we're done. All right, so I'm going to just use the 2 kilogram block. So I'm going to say, hey, on my 2 kilogram block, I'm going to sum the forces on that 2 kilogram block in the x equals mass of that 2 kilogram times the acceleration in the x. All right, I've got 2 forces in the x direction on this individual block. I got my force of contact, which is to the left, so 4 on 2, because that's what I'm looking for. And then I have that plus force of the push. The mass, remember, is not system when you're using an individual block. It's just that individual mass, which is 2, times my acceleration, which we've already found. All right, I'm looking for this. So I'm going to solve first in variables before I plug in numbers. I'm going to add that to both sides, and I'm going to subtract 2. Let's not put in my mass yet. Let's just do M2. I'm going to subtract this from both sides. So it's going to look like this. I have force of contact of 4 on 2 equals force of the pull, and again, sloppy with that, sorry about that, it just takes more time, minus, I'm going to subtract M2 times my acceleration in the x. All right, so all I did was I added force of contact to both sides, and I subtracted that mass times acceleration to both sides. I subtracted. Now I have an expression for that contact force, and I can plug in my numbers. This was 30. I'm using that individual block of 2 kilograms, so it's just 2, and my acceleration is 2.5. That's 30 minus 5, so that's going to be a contact force of 25 newtons is your contact force of 4 on 2, which also is equal to what 4 puts on 2 is equal to the force that 2 puts on 4, which is 25 newtons. And there you go. Now, if we went back to our free body diagrams on that before we sign off here, is that 4 on 6, those two should be equal lengths, but smaller, and these contact forces here should be a little bit longer, but again, equal. So this should have been a little longer, but equal. And still less than that force of push, because the whole thing's moving to the east. All right, perfect. I hope that helps sort out how to do these. First, do your free body diagrams, 1 for every block. 2, find that acceleration by summing the forces as a system, and then use those individual blocks to find your contact forces. Thank you, and happy physicsing.